Hey guys, today I'll be explaining 30, 60, 90 triangles to you. So let me just first write out 30, 60, 90 triangle. So this is a special type of special right triangle. The other special right triangle out there is a 45, 45, 90 triangle. And how it works is these 30, 60, 90, these values represent the angle measure. So here you could see 30, that's a 90, and this is 60. And how I like looking at it is the 30 is always facing the shortest leg, 60 is always facing the longest leg, and 90 is always facing the hypotenuse. So based off the based off based off which one's the largest, which one's the smallest angle, you're able to figure out what side it's opposite to. And how it works is there's side length ratios which are used, and this allows you to use one side length to solve for other side lengths, or to use all the side lengths to figure out whether it's a 30, 60, 90 triangle or a normal right triangle or some normal other right triangle. And these ratios are x, x, 2x, and x root 3. Or you could also look at it like this, 1, 2, and root 3. So what you can do is if you're given one side length, using these ratios, you could solve for another side length or the other two side lengths. And if you're given all three sides, you could use them to figure out whether it's a 30, 60, 90 triangle or not. So here in this one, I give you the shortest leg, and you're supposed to solve for the hypotenuse and the longest leg. So this is x, this is x, this is 2x, and this is x root 3. So what I do is I write out what the actual ratios are before. So since you know x is 4, you know this is 8. And since you know x is 4 here, this is 4 root 3. So that's that. Here, I give you the hypotenuse. The hypotenuse is 6. So using this, you're supposed to solve for the shortest leg and the longest leg. So since this is equivalent to 2x, you know x is equal to 3. So I have to write above. So you know this is that 3 because this is x. And since this is x root 3, you know this is 3 root 3. So if you're given the hypotenuse or the shortest leg, it's really easy to solve for the other sides. However, it can get a bit difficult when you're given the longest leg, because you're not going to always have it in the form of x root 3, where you can always just find the root 3 and the x. This is this actual whole number, 8. So what you're supposed to do here is you're supposed to take the 8 and divide by root 3 to find the x value. So since there's a square root in the denominator, you get the rationalize. So you multiply root 3 up top, root 3 at the denominator, and you get 8 root 3 over 3. So you know that's the x value. And now you have to multiply by 2 to find the hypotenuse. This is 2x. So you multiply this by 2 over 1, and you get 16 root 3 over 3. So here you have 16 root 3 over 3. So that's how you solve for those. So it still is pretty simple, just not as simple as these. And here in this problem, you're given all three sides, and you're supposed to figure out whether it's a 30, 60, 90 triangle. So what I like doing here is I first like taking the longest leg, 6, and divided by root 3. So 6 divided by root 3. Oh, sorry. Multiply by root 3 up top, root 3 below, and you get 6 root 3 over 3, which is equivalent to 2 root 3 over 3. Sorry, 2 root 3. So here you can see that the shortest leg and the longest leg both match up in the 30, 60, 90 relation. And now we just have to make sure that the shortest leg, if multiplied by 2, will be equal to the hypotenuse. So 2 root 3 times 2 is equivalent to 4 root 3. And that's what our hypotenuse is here. So we figure out that this is also a 30, 60, and 90 degree triangle. So overall, that's it. That's what a 30, 60, 90 triangle is, one of the special right triangles out there. In my next video, I'll be talking about 45, 45, 90 triangle. 45, 45, 90 triangle. That's another type of special right triangle. And I hope you guys can subscribe and like the video. And I hope to see you guys next time.